It's great to be back at Connect. It's great to see so many people here. I must admit, I was really surprised when Lenaro invited me back to present at Connect this year, because I stood on stage last year, and the first thing I did was talk about another conference. We were fresh out of Embedded World, and there was just so much going on, and so I came on stage and I stood up and I said, you all should have been at Embedded World. It's amazing how much stuff's there. And someone told me after the conference, if you're invited to do a conference, especially if you're a keynote speaker, you really shouldn't open by talking about another conference. And so when I was invited back this year, I said, okay, I will come back, and I promise I will not talk about Embedded World. So I'm not going to talk about Embedded World. I'm going to talk about another conference. Because a few weeks ago, I was at GTC. And GTC is a really, really great place to go if you want to have conversations about everything that's happening in AI. Of course, it's not the best place to go. Connect's the best place to go. And as good as Jensen Huang is, he's no Grant Likely, so That all being said, the array of capabilities, the breadth of use cases that were being presented at GTC were pretty incredible. The conversations that I was having with people who were doing things from cancer imaging, detecting tumors on certain images, all the way up to people doing surgical robotics and things like that. It's really pretty incredible to see the pervasiveness of a lot of the things that we're talking about and how that's now being brought through, and how many large companies and how many startups are working on this stuff. So it was a really, really interesting place to be, and it was a great way to spend a week. Speaking of pervasiveness of artificial intelligence, who knows what this is? Wallace and Gromit, yeah. For those of you who don't know, this is a British television series called Wallace and Gromit. It's created by a man from my hometown, very talented guy, Nick Parks. Originally, it was created using plasticine figures, so they'd do these like stop-motion things, and they'd have plasticine figures way ahead of its time. It's, I think, from the 90s, I think. So Wallace on the left here is an inventor. He comes up with all sorts of weird and wonderful ways to make his life simpler in theory and far more complicated in reality. And so he does all sorts of things, like have contraptions in his house where he can get out of bed and he comes down this slide, and he'll get dressed on the way, and then he'll land in his dining room chair to a plate of eggs and toast or whatever, assuming the house hasn't been set on fire in the meantime. Gromit is Wallace's trusty sidekick, the dog there. In England, Christmas Day is a big day for television, December 25th, and there is always these Christmas specials. And this year, the special of Wallace and Gromit, Wallace decided that Gromit wasn't doing a good enough job of tending to the garden, and so he created Norbot, the robot you see here in the middle, to do a fantastic job of tending the garden and doing that instead, which all worked really, really well, and the village was happy, and Norbot ended up being contracted out. Everyone's sat there now thinking, what's he going on about? Why is he talking about this thing? There's a villain of the piece. There's a penguin in this television series, Feathers McGraw. And from his prison cell, Feathers McGraw somehow managed to find a vulnerability in Norbot so that when he was charging at night, he exploited this vulnerability, and he uploaded a new firmware image to the robot that turned him evil, and he ended up terrorizing the village, and lots of bad things happened. Why am I talking about this? Two reasons. First of all, Grant already mentioned CRA, so security is really, really important, and the real-world impact of a lot of what we're talking about, whether it happens in a animated television series or whether it happens in the real world, are things that we should care about. And also, again, the pervasiveness of AI. I really didn't think I'd be sat watching television with my Sunday lunch, listening to a broad English accent talk about artificial intelligence for an hour and a half, but it's 2025, and here we are. In reality, this is more like the kind of things that we're seeing, at least in my part of the business. This is a module from a company called Zebra, I think. This is a camera LiDAR capable device. This kind of example is something we hear about and see quite a lot. So in this example, you have something coming off a production line, and we have the unit here, which is capable of both looking at metrics of how much stuff's coming from the line, but also doing things like fault detection. There are lots of constraints associated with a device of this size doing something that's that complex. Whether that's a thermal constraint, whether that's latency to understand what's happening as things are moving across it on a production line. And it's something that we are very aware of in the IoT and edge business at Arm as we're looking at different products that we're bringing to the market. And last year I stood here and I spoke about our latest embedded MPU, the Ethos U85. And that was really targeting embedded applications paired with microcontrollers. One of the big things that we launched this year was the Cortex-A320. So this is something that we've been working on for quite some time. We were excited to launch this a couple of months ago now. And it really delivers two things. In terms of compute performance and capability, compared to the Cortex-A35, you're going to see a 10 times increase in machine learning performance with the Cortex-A320. This is the first V9 core targeting ultra-efficient IoT applications. And in terms of general compute performance, you also see a 30% performance increase above the A35 as well. What's really impressive about the A320 is it's significantly more energy efficient than our previous high-efficiency core. So compared to the A520, you're working with a power envelope which is around 50% more energy efficient. So for the kinds of applications such as that module looking at things coming off a production line, for example, it's far more, it's really targeting that kind of application with the capability that's being delivered here. I mentioned that I spoke about the U85 last year. Traditionally, we've packaged the Ethos U with microcontrollers. So last year, we spoke about Corestone 320 in particular, which brought together the M85 with the U85. The Ethos U85 gives you 4 TOPS of performance, and it was traditionally paired with that M plus U configuration. One of the things that we're working on with the launch of the A320 is driver capability to run this alongside a Cortex-A. So rather than have to have a configuration where we have an A core and then an M plus U subsystem, we're going to be providing driver support to directly run the U85 alongside the A320. And in this configuration, we can run parameter models of over 1 billion parameters. What's the purpose of bringing V9 to IoT? Well, there's a whole breadth of capability that previously has been restricted to other parts of our business in either the mobile space or the server space. And this level of capability to bring down into the IoT is really significant. I spoke about security already, but things like memory tagging extension, or MTE, for increased memory safety, PAC BTI for control flow integrity, and also from a software isolation perspective, V9 architecture gives you secure EL2. Looking at that performance uplift and also the energy efficiency gains that we get from A320 as well, a lot of that is because of the specific extensions in the V9 architecture that allow you to do things such as matrix multiplication with the scalar vector extension as well, SVE2 capability. Running these kind of workloads on general compute without extensions specifically in the architecture to do that in both a performant and efficient way is going to mean that these devices are going to run really, really hot, and we also probably can't fit it into the power envelope that's required in a lot of embedded applications. And so we think we're going to see the A320 fitting in really nicely to a lot of the use cases that we're seeing as it pertains to Edge AI. So I mentioned the A320 is our ultra-efficiency V9 core. There's also the A520 as well, which was our previously most efficient V9 core for running AI applications as well. We're really thinking that 320 is going to target a lot of the IoT applications that we're interested in. So things such as smart vision applications, battery-powered devices, where energy management is an important consideration as well. Of course, this is a software conference, and so rather than just talk about the architecture for 10 minutes, I will also talk about some of the software support that we're providing for this as well. At Arm, we partner with AWS to provide reference implementations of FreeRTOS. We're continuing to do that. In particular, we see a bit of a demand for, it's a bit of a crossover space where people are saying, well, I have an M85 or a high-end M-core. What happens if I have an ultra-efficient A-core? Can I bring some of my real-time workloads over, either core pinning an RTOS to one of the cores or in a different configuration? We're also getting requests a lot for Zephyr. So there's a lot of demand for Zephyr as it pertains to real-time workloads. And so we're making sure that there's feature parity between the reference implementations that's provided through FreeRTOS and also what we're working on to enable the Zephyr community as well. And we're continuing to do that. Of course, there's native support for Linux. All of those architectural capabilities I mentioned earlier are all supported in mainline kernel. And Android's interesting in our part of the business, of course. A lot of people associate Android with the mobile space. In applications such as point of sale, in particular, we're seeing a lot of demand for Android, and so that's an area that we're looking to support with the A320 as well. Grant mentioned OneLab. I'd like to build on some of what Grant said. This is a really complicated area, and these are very complicated system deployments. It's very unlikely that in any kind of distributed system that's enabling the sorts of use cases that I've been talking about, we're going to have the same silicon platform or the same board vendor supplying all of the units for a given configuration. Interoperability is really, really important. And making sure that not just the base firmware layers are built and provided in a standard way, building on things such as the System Ready initiatives and PSA and the components that we provide alongside that, but also looking at some of the middleware components and even some of the application workloads. If I'm a board vendor and I'm looking to source a silicon platform for an upcoming product, how do I know what level of capability I'm going to get? How do I know if it's CRA compliant? How do I know that it builds on all of the standards that a lot of people in this room are discussing and putting together? OneLab is an environment by which we're bringing together not just silicon platforms, but boards and a whole host of software workloads to make sure that we have that level of interoperability across the ARM ecosystem. I do want to just take a moment to thank everybody that's been involved in OneLab since we launched it last year. I think it was last year. We've already had some great discussions. If you're not involved in those discussions, please feel free to come and speak to myself or any of the team over the next few days. We'd be more than happy to tell you about what's going on there. I'm just about out of time, and I think that's me. I just want to say thank you for your time. Have a great Connect, and I look forward to speaking to many of you this week. Thank you.